Hello everyone, welcome back to the channel Devotion of Knowledge. Again, here we are back again with another YouTube video, and in this video we are going to discuss a very important question that almost all the engineers are having in their mind, but there are very few of them who actually know the reason behind that why arrays actually follow zero based indexing. Now, those who are not aware, array is a array is a collection of elements like this. I have stored here 1, 3, 10, 100. These are the elements that I have stored in the array, and to access this value, which is the second value of the array, I have to write arr of 1. Let the name of this array be arr. So to access this particular element, I have to write arr of 1. Similarly, to access the first element of the array, I have to write arr of 0. Means, as you can see, to access the first element, I have to write arr of 0. To access the second element of the array, I have to write arr of 1. So here we are writing the value -1 as per the sequence number to get the value which is stored in the array. But why? For that, we as an engineer or any individual should know that what kind of memory allocation do arrays follow. Now, those who are not aware about memory allocation, whenever we are writing, for example, integer a equal to 4, so inside the computer memory there is certain memory allocated to this particular line. For example, as here it is integer is of 4 bytes. So 4 into 8, which is 32 bits. So there will be 32 bits which will be reserved for this particular int a equal to 4 integer. Now, what is 32 bits? Consider this as a one memory block. 1, 2, 3, 4, 5, 6 dot 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 dot. Such 32 bits are there, and each comprises of the value either 0 or 1. So this is for integer. But what is the case for arrays? Just a second. Yeah, what is the case for arrays? Arrays follow contiguous memory allocation. Arrays follows contiguous memory allocation. Now, what is this? For example, if I am declaring array of integer arr of 4, this means array is created of 4 elements. Now, how these 4 elements will be stored? They will be stored in a contiguous manner. Now, what is this contiguous manner? For example, if the first element is stored here at the memory address of 1, 0, 0 and 1, so the next element will be stored, if this is stored at the location of 1000, then another memory block will be at the location 1004, because as I said, integer requires 4 bytes. So this is for the first element, this is for the second element. 1008 will be the location of the third element, and 1012 will be the location for the fourth element. So these are the 4 elements, 1, 2, 3 and 4, and they all will be stored contiguous manner, means 1000, 1004, 1008, 1012. If I talk in simple language, they are stored in a continuous sequence. Right? Okay, now we know that arrays follow continuous memory allocation. But what is the relation between this memory allocation and zero based indexing? Okay, let us move forward. Let us consider this array of 4 elements. The address of this element is 1000, 1004, 1008 and 1012. And this is the integer array of 4 elements. Elements that are stored here are 10, 100, 400, random value you can take 500. So this is the array given. Now, to get this element from array, the computer should be given, or computers the compiler should know that at what address element is stored. So what is the address over here? It is 1000. So compiler uses the formula. If I consider zero based indexing, see, the first element of the array is called base address. So 1000 is the base address, 1000 is the base address. So if it is a zero based, the compiler follows the formula to calculate the address equal to base address plus index into size of data type. This is the formula that compiler follows. Just a second. This is the formula that compiler follows to calculate the address. For example, if I want to calculate the address of this third element, then what will be the address? 1008. It is equal to base address, which is 1000, plus what is the index that we are writing? Index is whatever value that we are writing inside the parenthesis while accessing the value. So it will be 0, 1 and 2. It will be 2 into what is the size of the data byte or data type? Integer. It comprises of 4 bytes. So 2 into 4. So 1000 plus 8, it will be equal to 1000. And so this is the location where the memory 400 is stored, and the computer will receive, the program will get this address, and it will return the value which is 400 stored at this address. This was the case if we follow zero based indexing. But similarly, if we want to follow one based indexing, what will be the formula? In that case, simple. If I am writing ARR of 3 to get this element, right? Instead here we are writing ARR of 2 to get this element. But if we are following one based indexing, then we have to write ARR of 3. So what will be the formula accordingly? Base address plus index minus 1 into size of data type. Simple. This is the formula for that. Simple. So to get this element 400, we have to write ARR of 3. ARR of 3 will be 1000 plus 3 minus 1 into 4, and it will give finally 1008. And both the results are identical. So in one based, this is the formula. For zero based, this is the formula that we are following. But why this one is more preferred as compared to this one? Now answer lies in front of you. Just see and compare this particular formula and this particular formula. What is the difference? Nothing. The only difference lies over here, which is index and index minus 1. This is the formula which is executed inside the backend during the compilation of the program to find or to get the particular value stored at the index. And this is the same formula which is used for zero based. This one is for one based. Now why this one is preferred over this? Because of this extra arithmetic operation that is being executed in one based indexing. See, whenever the compiler and all the systems are designed, the main thing that it follows, it should be most optimized. So most optimized way of calculating indexing means whatever things are designed, they should be most optimized. So over here, if we are following zero based indexing, this is the only equation that is being executed. But if we are following one based indexing, then base address plus this minus 1 is the extra operation that is being undergone to get the element. So this minus 1 is relatively a costly operation, but you are observing and seeing that this is only just an minus operator. And how much time it will take? No, for us right now it is a very simple operation, but whenever compilers and all the things are designed, there are millions of operations going into backend every second, and arrays are very integral part of the design. So arrays are used at each and every step, and in those millions of operation, every operation should be highly optimized. So this -1 or this decrement operator is not advisable, or it's not very cheaper. It is highly expensive at the level of compiler, because as I said, millions and billions of operations are going each and every second. So this decrement operator of 1 is quite expensive in our case, means in the case of compiler design and all that. So this is the main reason because of which arrays follow zero based indexing in almost all the languages that we are familiar with, whether it is C++, Python, Java, etc, etc, and one based indexing. Because see, Python and all, they are very heavy languages themselves, and if they are following one based indexing, then it will create unnecessary unwanted overhead on them. So this is the reason, -1 is the reason behind following zero based indexing rather than following one based indexing. So yeah, I think we should conclude over here, and this is it from my side for this video. If you guys have any feedback, any question, please feel free to write in the comment section below. And yes, this is the very simple reason behind following zero based indexing, but believe me, very good engineers are even unaware about this particular thing, that why zero based indexing is followed. So yes, feel free to write anything in the comment section below. We'll be meeting in the next video very soon. Till then, keep learning and keep hard working. Thank you very much.